In this video, I will go over a problem involving one-dimensional kinematic equation. The problem states that there is a man running at a speed of 6 meters per second and a bus is accelerating at a rate of 1.0 meters per second squared. Initially, the distance between the man and the bus is 25 meters. And the problem is asking if the man will be able to reach or catch the bus at a speed that he is going. And this is his maximum speed. He is not accelerating after that. So in order to solve these problems, we have to set the position of the man and the position of the bus equal to each other. Because the man, if he is able to catch the bus, then his position and the bus position will be equal. So that's what we're going to do. We have to set them equal to each other. In this problem, I would use blue for the bus and red for the man. And it's also a good time to set the coordinate system. We'll choose this to be x0, the initial position at 0, and this is positive x direction. To start off, let's start with blue for the bus. Position of the bus is x0 plus initial speed of the bus plus 1/2 acceleration of the bus, d squared. We know that initial position is 25 of the bus. If this is the initial position, x equal to 0, then the bus is 25 meters ahead. Then we write 25 plus the initial velocity of the bus is 0 because it's starting from rest, but it's accelerating at a rate of 1 meter per second squared. But the initial position is 0. It was stopped. The initial velocity is 0, so VB is 0. Then we write 1/2 acceleration is 1 times t squared. So this is xb. The position of the man, the initial position of the man is 0, and the speed is 6 meters per second, 6 times t. And we said that this man is not accelerating because that's his maximum speed. He's not accelerating, he's not going faster after 6 meters per second. So this is the position of the man. So we need to set these two equal to each other. xb equal to xm. 25 plus 1/2 t squared is equal to 6t. I can write this as 0.5 t squared minus 6t plus 25 equal to 0. This equation is a quadratic equation, and we can solve this using the quadratic equation formula. So in order to solve this for t1, t2, we need to do negative b plus or minus b squared minus 4ac divided by 2a. As we know, this is a, this is b, and this is c. So the question asked if the man is able to, after running, if he is able to catch the bus. In order to know, to know whether he will catch it or not, we need to look at this value right here. This is called the discriminant of the equation. B squared minus 4ac is called the discriminant, is under the square root. If this value is less than 0, then there is no solution, which means the man will not be able to catch the bus. Because if you have a negative under a square root, that doesn't make sense. Or you have a complex solution. So this cannot be less than 0. If it is less than 0, no solution. If it is equal to 0, b squared minus 4ac is equal to 0, then this means, so this is no solution, this means only one solution. And b squared minus 4ac greater than 0, you have two solutions. So we need these two. Meaning if we get this scenario, these two scenarios, then the man is able to catch the bus. But if it's negative, then there's no solution. Therefore, negative b in this case is negative negative 6. So 6 plus or minus square root of 36 minus 4 times 1 over 2 times 25 divided by 1. If we look inside the square root, you have 36 minus 50, which is equal to negative 14. And this is less than 0. Therefore, the conclusion is the man will not catch the bus. So this was part A. Now we'll do part B. Part B instead says, what if the acceleration of the bus is 1/2 meters per second squared? Will the man be able to catch the bus? And we'll do the same procedure. We know that from part A, x of the man is 60. And xb is going to be 25 plus 1/2 times 1/2 t squared. xb then is 25 plus 1 over 4 t squared. If we set xb equal to xm, we get 0.25 t squared plus 25 equal to 6t, 0.25 t squared minus 6t plus 25 equal to 0. This is again a quadratic equation, and you have 6 plus or minus square root of 36 minus 4 times 1/4 times 25 over 2 times 1/4. It's 2. This cancels. So as we said earlier, the discriminant, that is what is inside the radical, we have a positive number greater than 0. And we said that we have two solutions. That means the man is going to catch the bus 2 times. Okay, but we only need when he catches the first time. That's what we need, because he doesn't need to run after that. You just need to catch the bus, and then that would be the first or the initial intersection. So you have 6 plus square root of 11 divided by 0.5, or 6 minus square root of 11 divided by 0.5. This is 18.63, and this is 5.37 seconds. remember we're finding time because the variable here is t. We need this time, that is the first instant when the man catches the bus, at time equal to 5.37 seconds.